Hello and thanks for watching Gary Teaches Maths. I'm continuing to go through the Edexcel higher tier paper from June 2018 and this is paper 3. So we're on question 16 and this is a question about sequences. The first part, we've got this sequence which is actually a quadratic sequence because it's got an n squared in it. So this is an squared plus bn will give us the nth term of the sequence. So really we can create an equation like that. So that the nth term is equal to an squared plus bn, where n is actually the position that we are in the sequence. So if we look at this first value, we're given that the second term in the sequence is -2. Then what we could say is -2 is the second term, so we can replace this nth term bit by saying -2. Because that's what it is, and then we can replace n by 2 here and here. So what we'll get is a times 2 squared plus b times 2. And so we end up with, if we tidy that up, we end up with -2 equals 2 squared is 4, so it's 4a plus 2b. And really, our job to begin with is to find the values of a and b, which are going to be numbers, so integers, so whole numbers is what they are. And once we've got that, we'll have the equation for the nth term, but we will have the numbers a and b, and that will enable us to find what the sixth term is. So we're going to then look at the second piece of information that we've got, and this is that the fourth term is 12. So we can say, right, well, 12 is going to be equal to, replacing n by 4 here, we're going to have a times 4 squared plus, and then we've got to replace the n again by 4, b times 4. So that's going to give us that 12 is equal to 16a, because 4 squared is 16, plus 4b. And we can actually simplify that one by, we could just divide through there by 4. We could do, so if we divide through every term here by 4, I'm just going to try and make this a simpler equation, because we can see 4 is a factor of every number in here. So if I do that, I'd end up with 3 is equal to 4a plus b. So that's one equation, and we can actually do a similar thing to this one. I'm going to divide through by 2 because every number there is a factor, is a multiple of 2. So if I do that to that one, divide through by 2, what I'll end up with is -1 equals 2a plus b. Okay, so we've got two equations there. I'm going to just alter the order I'm writing them in. So I'm going to write this one, number 1 at the top. I'm going to say 4a plus b equals 3. And then if I write this one below, number 2, equation number 2, I've got 2a plus b equals -1. And you may be familiar with this. What we've created is two simultaneous equations because we've got two equations and we've got two unknowns in the equation. So we can deal with this by the elimination method, which is when the coefficients are the same, either for the a's or b's, which that means the number multiplying either the a's or b's are the same in both equations, we can subtract or add to remove one of the variables. So we can see we've got really the same number of b's in both parts. We've got a 1b there and a 1b there. So if I subtract this equation here from the one above, we will eliminate the b. So we'll end up with 4a take away 2a is 2a. b minus b actually disappears. And so we end up with 3 take away -1. So 3 minus -1 becomes 3 plus 1, which is 4. Then we've just got a simple matter of dividing through by 2. So we get that A is equal to 2 if I divide both sides of that equation by 2. So we found one of the values, and now we just need to find the second value. We need to find B. So if we take this value of A that we've found and we substitute it into, well, I'm going to choose this second equation here because that's the simpler one. If I substitute it into that, what I'll end up with is 2 times 2, which is the value of A, plus B equals minus 1. So then, just working that out, I get 4 plus B equals minus 1. And then I'm going to subtract 4 from both sides, take away 4, and I'll end up with B equals minus 1, take away 4 is going to be minus 5. So I've got me two values, A and B. And if I want to, I'm just going to do this here, I can use the other equation that I've created just to confirm that I did get the right answer. So if I substitute A equals the 2 that we got and B equals the minus 5, we should get 3. So let's just have a look at that. So we're going to get 4 times the 2. Just put a little bracket there so we can see where the substituted number is. And then plus, and it's minus 5. So there we go. And let's see what that works out. So we end up with 8, and then a plus and a minus next to each other is a minus. So 8 minus 3, 8 minus 5, which does give us 3. So we've done that part, and that does work because that actually agrees with the answer. So we found our value for A and B, and what that means is we can then say our nth term is now given by this same equation, but with the values of A and B substituted in that we've just found. So we can say it's equal to 2n squared and then minus 5n. So we're now in a position to be able to find what the sixth term is. All we need to do is replace the n by 6 in this equation. So we say, right, well, the sixth term is equal to 2 times, replacing n by 6, we get 6 squared minus 5 times 6. And if I work that out, that's 2 times 36 minus 30. So I'm just running out a little bit of space here, but 2 times 36 is 72. Take away 30 is equal to 42. So that is our answer to the sixth term in the sequence. So that equals 42. So this first part really was about finding the values of A and B using simultaneous equations, and then from that creating our general equation for the nth term here. And then once we've got that, we substitute in the value of n equals 6, and we get 42 as our answer. So there is our answer to the first part, 42. So if we now look at part B, we've got, here are the first 5 terms of a different quadratic sequence. So it's a different one. Okay. And a quadratic, again, is something that has a squared term in it. Like the one above, we had n squared in that. So that meant it was a quadratic sequence. So we've got to find an expression in terms of n, the nth term of this sequence. So I'll just write it here again. So 0, 2, 6, 12, and 20. So the first step on this is usually to find the differences. Okay, so I'm going to look at the differences, see what steps it goes up in. So it goes up in 2, 4, 6, and then 12 to 20 is 8. And then we can say, okay, let's look at this part now of the second row differences. And we can say, right, this is going up by 2, this is going up by 2, and this is going up by 2. So the importance of that is that if we have a quadratic sequence, then it's actually of the form where we have the nth term is equal to an squared plus bn plus c. And it's a case of trying to find these different integers. So the integers being a, b, and c. Now, the a term is always half of these second row differences. So that's just something that we need to remember, really. So if I call this equals d, the differences, so d equals 2, then the a value there, a, is equal to d over 2, so a equals 1. So that means I can actually find the value for a there. I can replace a by 1. So that means we've simplified it a bit. We can say the nth term is equal to, replacing a by 1 just gives me n squared plus bn plus c. And what we're going to do is we're going to look at the first term in the sequence. Now, for the first term, n equals 1. So we could say, let's look at the n value for each. N is the position in the sequence. So for the first term, n is equal to 1. There it's equal to 2, 3, 4, and 5. So that's the value of n. So if we look at that first one, we can see that the nth term, first term, is actually 0. So 0 equals, and then just replacing n by 1, we get 1 squared plus, and then b times 1 is just b plus c. So if I tidy that up, I could just say I'm going to take the 1 squared is 1, and I'm going to subtract it so it goes on the other side, and I end up with b plus c equals minus 1. So this is the first term. If I look at the second term, what I'm going to get is the second term, you can see, is 2. So I'm going to get 2 is equal to, again, replacing n by the value that we're just saying it is, which is 2. You can say we get 2 squared, which is 4, plus 2b plus c. Which again, if I take away the 4 on the other side, so if I subtract 4 from both sides there, what I'll create is an equation which is got just a 2b plus the c equals minus 2. 4 take away 2, 2 take away 4 being minus 2. And what we've got is two simultaneous equations then. Similar to before, we've got two simultaneous equations. So we need to find values of b and c. So what I'm going to do is I'm going to call this equation 1. I'm going to call this equation 2. I'm actually going to take away equation 2 from equation 1. And if I do that, I'll get 2b take away b is just b. And then the c's would disappear because we've got c take away c, just disappears. And I would have minus 2 minus minus 1. So minus 2 minus minus 1 is the same as minus 2 plus 1. And that's because a minus and a minus together equals a plus. So minus 2 take away minus 1 is actually minus 1. So we found the value of b. So next thing we need to do is we need to find the value of c. I'm just going to create a little bit of space here as I'm running out of space. So I'm just going to rub all this stuff out from before just to create a bit of space to continue. Obviously, you can stop the video at any point so you can go back to what I was looking at. previously. So if we continue from there, we found that b is equal to -1. So I'm going to go up to here. B is equal to -1, and we can now use equation 2 to find out the value of c. So I'm going to just write that again. B plus c equals -1. I'm going to replace the b by -1. So I'm going to get -1 plus c equals -1. So all I need to do then is add 1 to both sides. So add 1 there, and we end up with c is equal to 0. Having got the value of c and the value of b and the value of a, we can just put them all back in here. So there's our nth term. So our nth term is given by an squared plus bn plus c, but not forgetting we found that b is equal to -1, c is equal to 0, and then earlier here we found that a equals 1. So that means our nth term is equal to n squared minus n, and that's it. We've done it. So there are other ways of doing this type of equation. This is the one I prefer, and so by creating simultaneous equations. So I hope that's been helpful to you. If it has, please like our video and subscribe to our channel, which is Gary Teaches Maths. And for more help, visit our website, which is at the top of the page here, which is bestmathstutors.co.uk. Where you can find lots of videos on past papers and also articles on maths and actually tuition if that's what you're looking for as well. So thanks for watching.